All right, everyone. Hi, this is Mr. H. We are going to be starting a new topic this week. Is going to be functions, and the very first image that I wanted to start with is this on my iPad. I have an image of a vending machine, and everyone knows how a vending machine works, right? You put your money in, you press the button of the item that you want, and then that item falls out, and you get it. Basically, that's what a function is, right? So in this case, let's say you put in your money, you press your input keys. Let's say we press A0, and then after that, the Lay's potato chips will fall out. Now, every function works just like that. You put in your input, right? And you get one and only one output. So when I press the A0 key, I don't expect two bags of Lay's potato chips to fall out. I expect one bag to fall out. Every time I put in my input, my money, I expect to get one item out. I don't expect to get two, three. That's what a function does. Also, the other thing is, whenever I press the A0 key, I expect Lay's potato chips. I don't expect Lay's potato chips one time, and then the next time I'm going to get a Snickers bar. Every time I should get a Lay's potato chips. If you understand that, that's what a function is. So let's start with a more formal definition. All right. A function is basically a rule that converts an input into one and only one output. That's the key. I've circled it. One and only one output. Now, it's a rule. You can say it's a process. You can say it's a machine like the vending machine, but it's something that will take an input and it's going to convert it into one and only one output. Now let's look at a couple examples. All right, so here's a function machine. And the rule is we're going to take an input and we're going to triple it and then we're going to add 6 to it. That's what we're doing, right? So in particular, what we're going to do is right here, what we have, this is a function. This is a function. It says f of x equals 3x plus 6, right? And whenever you see f of x or g of x or something like that, that generally indicates that you're dealing with the function. And what that means specifically is we're going to replace the x with the input. So let's do that. So we're going to take the 5 and we're going to input it, and where we see an x, we're going to replace it. So that's going to be 3 times 5 plus 6. So 3 times 5 is 15. 15 plus 6 is 21. So the output, when the output is going to be 21 when the input is 5. Now let's go to a different one. So let's say we want to put in the input of 8, right? So that's going to be 3 times 8, which is 24. 24 plus 6, that's going to be 30. So that means that when the input is 8, the output is going to be 30. And then let's look at this last one. It says if the input is 20, right? 3 times 20 is 60. 60 plus 6 is going to be 66. So that's going to be our output. That's what a function does. It takes in an input and it creates an output. One and only one output. All right, now here's another one. Now this one, it doesn't always have to be numbers. It could be money, it could be months, it could be anything, right? But every time you put in an input, you should get one and only one output. That's what makes it a function. So let's do this. So this is saying, if you tell me what the month is, I can tell you the number of days in that month. That's what the rule is. So if we start with November, November has 30 days, so the output would be 30. All right. How about December? If we input December, the output is going to be 31 since there are 31 days in December. Now, if the input is January, the output is still going to be 31 because January has 31 days. Now, when we get to February, right? February is a little different. February, it depends on whether it's a leap year or if it's a non-leap year. This year, February had 29 days. Next year is only going to have 28 days. Now, every time I press the February key, I should get either 28 or 29. The fact that I could get two different outputs means that this is not a function. All right, it is not a function because every time I press the February key, I should always get 28 or I should always get 29. It shouldn't be one or the other. All right, let's move on. All right, now, one of the things that you should be able to do is when you look at some data, you should be able to say, oh, that is a function or that is not a function. One of the things that's useful is called a mapping diagram. And what that basically does is it takes all of the inputs and it puts them in like a little oval, and then all the outputs go in an oval. And then the arrows will map, like November goes to 30, has an arrow going to 30. January and December have arrows going to 31. All of that is good. Now the problem is with February. February has 2 arrows going to two different outputs. That's why it's not a function. Every input should have one and only one arrow. Always. Every input should have one and only one arrow. All right, so let's look at a couple of things. First, let's do a little vocabulary. Anytime all of the inputs for a function is considered the domain. So if someone says, what is the domain of this function? You have to go and you have to say, oh, here are all the inputs. So that would be the domain. If they ask you, what is the range? You should say, the range is all of the outputs for a particular function. Okay, so domain is input, range is outputs. Lastly, a relation is just a relationship between two values, right? It's a really loose term, and what we want to know is this just a relation or is it a function? So let's look at a couple other mapping diagrams. So my first question here is this a function, right? And you should say, yes, it is, because every input has only one arrow going. It doesn't matter that they're all going to the same output, right? As long as each input has one arrow going, originating from it, it's going to be a function. All right. Let's look at another one. Let's look at another one right here. And right now we have, is this a function? Is this mapping diagram a function? Yes or no? And you should say no, it is not, because this input here has 2 arrows going to 2 different outputs. So it is not a function. Okay, so mapping diagrams are very useful in trying to determine if something is a function or not. Now let's look at another one. Sometimes you're going to have a table of values and you still have to be able to look at it and go, is this table of value a function, right? And what you're going to do is basically, if you see an input that repeats itself, it cannot be a function. And let's use that. So here, if we look at the first table, it says the input is 2, and it says we're going to get an output of 2. And then down here it says, oh, in this case, we're going to have an input of 2, but the output is going to be 6. So that cannot be a function if it has one input that gives you 2 different outputs. So this is not a function. Let's look at the h of x and see if that is a function. It has the same issue. You have an input of 2, you have an input of 2, but the outputs are different. Right? So whenever you press the 2 key, you should get Lay's potato chips. You shouldn't get Lay's potato chips and then get a Snickers bar, right? When you press that key, you should always get Lay's potato chips. And this is why this is not a function. Now, if we look at this table g of x, you can see that every input is unique. There is no overlap. There's no repeating. So this is a function, and that would be our answer. So the x cannot repeat. If it repeats, it's not a function. All right. The last thing that I want to look at is sometimes you're going to have graphs of functions, or you're going to have graphs, and you have to be able to determine, is this graph a function or is this graph not a function? What we're going to use is something called the vertical line test. And all that means is we're going to draw a vertical line down through the graph, and if it hits the graph in more than one place, it's not a function. All right. So I'm going to show you how that works. So here, I have a vertical line. Now, this first function, no matter where I draw that vertical line, it only hits the graph in one place. So that one would be a function. Now, this line here, the next graph, it's the same thing. Even though no matter where I put the vertical line, I only intersect the graph in one place. Now, let's go down here and look at this circle. This is not a function because no matter what, I'm hitting this circle in 2 places. So that means this is not a function. All right. Now, if I do that again, let's look at a couple others. Right. If I draw this vertical line here, same thing. It's hitting this graph in more than one place. So this is not a function, right? So when you're looking at a graph and you're trying to determine, is this a function? All you have to do is draw a vertical line like here. And if it hits the graph in two places, then it can't be a function, right? So right here, it hits in two places. It's not a function. That's all you're using. It's called the vertical line test. All right, guys. So for the Delta Math assignments, these are the skills that you're going to need in order to complete those assignments. All right. Thanks.